Assalamualaikum warahmatullahi wabarakatuh. I'll be to my panel, Technologist Aminul Rashid bin Nordin, and my second panel, Technologist Saliha binti Muhammad Saleh. My name is Muhammad Isa bin Ishaq, and I'm from Faculty of Electrical Electronic Engineering Technology. My supervisor name is Madam Rozilawati binti Muhammad Noor. Today, I will present to you about my bachelor degree project, the development of resistor sorting machine prototype by using Arduino. This is the poster for my bachelor degree project, development of resistor sorting machine prototype by using Arduino. This is my project overview for the introduction. For your information, resistor is a common use electronic equipment in the lab. And usually, this resistor have a different type and different value. For the type, usually in 4 band type or 5 band type. And for the value, it differ from 10 ohm until 10 kilo ohm. And this usually used in the laboratories. For my problem statement, this problem usually occur in lab session. Students and lab assistant has a problem to use the electronic equipment because this resistor usually in an improper state and miss out to different values. So this increase their time and their burden. Hence, this project proposed to develop a resistor sorting machine prototype by using Arduino to measure resistor by using multimeter to reduce the time and labor wastage. This system expected to measure the resistor and make sure the resistor fall in the correct bin and the out of range resistor in the reject container. The objective of this project is first, to develop a resistor sorting machine prototype by using Arduino. Second, to design sorting system for respective resistor by measuring resistor value range. And third, to analyze the effectiveness of the proposed system for sorting purpose. For the scope of this project will develop a prototype machine that will sort 3 types of resistor, which is 100 ohm, 500 ohm, and 1 kilo ohm. Also, the resistor must have a 4 band type and 1 other bin for out of range resistor from other 3 types. The system uses common resistor measured around 9.2 mm across, and the length of resistor must be in a straight parallel. Arduino Mega is the main controller used in this experiment together with multimeter to measure the value of respective resistor. This is my end product, which is my prototype for this project. This is the flowchart for my system workflow. So first of all, when I on the power supply, the LCD will turn on, server 1 and server 2 will at 0 degree, same with server 3. And then when the user put the resistor at the measurement station, the data will compare with data in Arduino. So this system will compare either the resistor in 100 ohm, 500 ohm, 1 kilo ohm, or other value from this tree. If the resistor value is 100 ohm, servo 3, which control the rotary bin, will rotate to 35 degree. If 500 ohm, it will rotate to 75 degree. 1 kilo ohm, it will rotate to 165 degree, and 135 degree, sorry. If out of range, it will turn to 165 degree. Then, after finish all this process, the rotary will rotate back to the initial position, which is 0 degree. Then this system will wait either the user want to put another resistor or not. If the user does not want to put another resistor, they can turn off the power supply. So the system will turn off. This is my result and analysis. So for the first graph, I choose this graph because this is the most stable result that I get from my analysis. For this first graph, it shows about the 500 ohm resistor sorting, but we sort it by using different value of non-resistor and human. So for this resistor, we sort by using 100 ohm, 500 ohm, 1 kilo ohm, and human as the non-resistor. So based on this graph, we can see that when we use 500 ohm as the non-resistor, the value of the resistor get the most accurate to the real result, to the real data. But when we use 100 ohm and 1 kilo ohm as the non-resistor, the value differ a little from the real data. But however, actually, if we compare to when we sort 100 ohm by using 1 kilo ohm non-resistor, the value differ very much because when we use 1 kilo ohm as the non-resistor, sometimes it measure the 100 ohm resistor as 80 ohm or 120 ohm. So this may cause the data to detect it as out of range data. And then for the next graph, this will show about the data that is the repeatability. So when we use 500 ohm as the non-resistor, it shows that the repeatability is the most stable. For the first try, second try, and third try, all 10 pieces of resistor managed to be soldered beautifully in the bin. Compared to when I use 100 ohm and 1 kilo ohm as the non-resistor, at the first try usually there will be two resistors that are wrongfully soldered, because like I told you before, the non-resistor value and the measure value is differ very much. For the third graph, it shows the time taken to measure between this machine and human. This data shows that the time taken used to sort by using this machine is greatly reduced compared to human, because as a human, when we want to measure the resistor using multimeter, we have to change the range of the multimeter. Every time you want to measure, we have to change. So this took a lot of time for the human to measure the resistor, because if we want to measure 100 ohm, we cannot use range of 20k, because if we use this range, then the value will not be stay at the multimeter. So students have to change their range every time they want to measure the resistor. Compared to by using this system, the user does not have to change the range every time. They just need to set the range at the beginning of the system, and then they let the machine to run and compare it by itself to get the result. Based on this analysis, it can show that 500 ohm is the best resistor to use as the non-resistor if I want to solve for 100 ohm, 500 ohm and 1 kilo ohm. In conclusion, all the objectives were achieved since the overall system development and evaluation process was succeeded. This project succeeded to develop a resistor sorting machine prototype by using Arduino, where our meter is applied in the machine. This machine also successfully measured and sorted the resistor value that has been chosen for this project scope, which are 100 ohm, 500 ohm and 1 kilo ohm. Based on the project analysis, this machine proved that time taken to measure and sort the resistor could be reduced greatly by using this machine compared to measure by human. This developed system will provide efficiency and reliability, which should play a vital role for better care. Development of the resistor sorting system gives us a chance to reduce the time taken to sort and help students to focus more time on lab with correct component. The system is one way of learning to enhance the new lifestyle. This is some of the reference that I used in my bachelor degree project. Alright, so this is my project. So as you can see in the display right now, resistor sorter. R1 is the non-resistor, which is I put 500 ohm, and R2 is the measure. Right now it's around 255,000 because there are no resistor. And the last one state the position of the bin. So right now the bin at initial position. As you can see, this is the initial position. This is for 100 ohm. This is for 500 ohm, 1 kilo ohm, and the reject one. So if I put an example of 100 ohm resistor, this is the example of 100 ohm resistor. So when I put 100 ohm, so it will turn to the 100 ohm, and this bin state. So if I put another 100 ohm, it will change to 100 ohm bin positions. So as you can see in this, okay, so this is the value and it changed to 100 ohm bin. So same goes if I put like this one is 500 ohm examples. So if I put 500 ohm, the bin will rotate to 500 ohm, and here we state 500 ohm bin. So for the second example, if I put another 500 ohm, it will change to the bins, and the value as you can see 501.96 and 500 ohm bin. Then it will return to initial position. Same goes to the third resistor, which is 1 kilo ohm. If I put 1 kilo ohm resistor, the value 171, and it put 1 kilo ohm bin. So this is in the range of 1 kilo ohm resistor. So if this is the real one, if I put 1 kilo ohm, then it will rotate to the third bin for 1 kilo ohm. Alright, so this I will show you the example for the reject product, because as you can see here we have 3 chosen resistor which we want to sort, which is 100, 500 and 1 kilo ohm. So here I have around 5 resistor to initiate the out of range resistor or reject resistor, which is 10 kilo ohm, 4.7 kilo ohm, 50 ohm, 6.7 kilo ohm and 730 ohm. So first of all, I will take the 50 ohm to show you. So as you can see, the value 58.34 out of range. So the next one, I take the 730 ohm. and then I will put here. So as you can see, the value is 713 out of range. And then the next one, I take the 4.7 kilo ohm to show you. Then when I put, so as you can see, oh, this is 2.7, so out of range, around 2.7 kilo ohm. So and then for the next one, this one is around, yes, around 6.7 kilo ohm out of range. And then for the last one is 10 kilo ohm resistor, so out of range also. The value is quite different to the real value of the resistor, because we put the R1 as 500 ohm. So if the measure resistor and non-resistor value is difference, has a high difference, so the reading become unstable. That's all for my presentation and my demonstration. Thank you very much.